Welcome everybody to Ask CTE Contributors. Today I have with me here Scott LaPrade from Genevieve Swiss Industries. Today's webinar is called Master the Art of Rotary Broaching, Revolutionizing Polygon Machining. And this is based off the Turn to Forum article in our July 2024 issue of Cutting Tool Engineering magazine. Once again, I have Scott LaPrade with us. He's the application supervisor at Genevieve Swiss Industries. Scott LaPrade has been with Genevieve Swiss Industries for over 20 years, helping machine shops that employ CNC Swiss-style machines with game-changing tooling and accessories, and specializes in helping Swiss machine users get the most benefit out of specialty machining techniques such as rotary broaching, knurling, and thread whirling. And with that, Scott, I will let you take it away. I know you have some great stuff to share.
Sounds great. First and foremost, Tim, thanks for the invite and for the opportunity to be able to put this little seminar together for the CTE viewers tuning in from probably all over the country right now and maybe even around the world a little bit here. Cutting Tool Engineering has been a partner of ours for a long time for doing advertising and some of the more traditional like print media type stuff. So getting to participate in a presentation like this is fantastic. So thank you for that. So first, to start it off, I just kind of want to do a little introduction of myself here. As Tim said, I'm Scott LaPrade. I've been with Genevieve Swiss Industries since 2004. So this is my 20th year in the tooling business. And one of the things that we do here at Gen Swiss is help users of Swiss-style CNC machines be more effective with their equipment. We offer tooling and accessories that are very good for advancing productivity or simply putting what we like to call process stability into the manufacturing system. So that way you've got more production at the end of the day. So that's a lot of what we try to do here. And on top of that, we try to make it so that it's easier for machine operators who run this kind of equipment to do their jobs. And that's where some of this broaching product comes into play here. So a little bit more on that whole concept of making the machinist's life easier. That's what this Swiss-style broaching system was introduced to do. So rotary broaching is not a new process. This is something that's been around for, I would probably estimate somewhere around 100 years or so. I don't know the exact history or the timeline of it, but it does go way back to manual machining back, in the early 1900s or so is around when it was invented. And the advancement that we came out with was one of the first things that I had to do when joining Gen Swiss. We introduced the 2160 series broach holder, the Swiss style adjustment free holder that you can see here in front of me. That was one of my first tasks when I came on board here at Gen Swiss, was to launch and promote this exciting new product. And what makes this so good compared to previous broaching systems that were out there is, first and foremost, it's a very compact system. So you can see the size of the broaching holders here is significantly smaller than product that was available to the industry prior to us introducing this. Anybody who's familiar with CNC Swiss style lathes understands that there's very little room inside of these for tooling, where you'd have adjacent positions perhaps getting interfered with when you have a large chunky tool holder in there. This tool holder was designed to be able to accommodate the tight working envelope that these machines commonly have. So the other thing about this that makes it really easy for operators to use is Swiss style machines are very accurate when you call an ID position up to center line. So it kind of makes it so that you don't need the old style tool holders anymore that had the adjustments that were built into them. Because one of the key things about rotary broaching is you need to be perfectly on center in order for it to be super effective. So the Swiss style machines are inherently accurate enough to accommodate that already. So all this holder does is makes it so that you can put this broaching tool easily on center with the workpiece that you're looking to broach. It's all built in and pre-calibrated by using controlled overall length broaching tools in the end of the holder. So with that, kind of want to go into a little bit more about exactly what is rotary broaching, and what kind of benefits can you realize by employing this in your manufacturing operations on a day-to-day basis. So rotary broaching can generate a regular shaped polygon on the ID of a workpiece. So the first thing that comes to mind in terms of an application that you might think of on that would be a screw, or something that has a drive feature for a final assembly, where you need to put an Allen key in there or a Torx key or something like that. So any kind of regular polygon is something that you could machine using this process, and it's fast. That's one of the great things about it, is it's fast, and you can do this in a single setup on a machine. So I'm going to reference CNC Swiss machines a lot here because that's just my knowledge base. But this also applies to turning centers, and you can also run this type of process in a vertical machining center. As long as something is rotating, you're able to do some rotary broaching on there. And again, the types of process, or the types of profiles that you're going to be looking at making, would be something that's regular and symmetrical all the way around. Those are going to be ideal scenarios for rotary broaching. So as I said, some of the benefits is you can do this kind of process and complete a part in a single setup, where you don't have to blank out the part, handle it, put it on another machine, put it on a press where you'd maybe be forming a socket into the end of it. You could actually machine this on the machine while your spindle is turning, and accomplish it in a matter of only a few seconds. The cycles are fast for producing a polygon form. So some good examples of parts that you might be looking at doing is, like, for example, I've got a kind of a socket in the end of a threaded plug. This is a part that one of my end users has made over the years, and I took it from my trophy case of successful broaching operations. Another good example here is a small electronics housing that has a Torx drive in the end of it. And I'll hold this up close so everybody can kind of see. One thing that we're going to get into here is we're going to talk about the chip displacement, or the material displacement that broaching produces, because that's one thing that we need to be all very cognizant of when we're working on this type of a product and doing this kind of a procedure in our machines. But here's another good example. And then the one that is kind of one of my favorites, and we see a lot of usage in rotary broaching, is in the medical field. So I've got a titanium bone screw here with a very tight tolerance hexagonal drive on the end of it. And again, this is one that was run at one of our users here, where we were doing some processing and developing improvements for them. So we left the chip inside the bore prior to drilling it out. We were doing a whole bunch of different ways of chip removal, and this just happened to be one of the pieces that I collected. But this is another very good example of an application that you might encounter, or something that you could apply this type of a process to. So who can use it? I did mention that already. Anybody who's running CNC Swiss style lathes. You could do it on a manual machines, like a manual lathe, a manual mill. I've personally been able to successfully rotary broach in a Bridgeport, for example. As long as something is rotating, you can make it work. So in a lathe, your part's going to be rotating, but on a milling center, the part will be stationary in the vise, and your broaching tool is going to come down in the spindle and engage the workpiece, but the holder will rotate while the tool engages the workpiece and becomes stationary. But you're still going to get the wobbling action that occurs that gives you the cutting. And we'll get into that in a few minutes about how that actually physically functions, because I think that's a little bit of the secret sauce to understanding how this process works, and will make you more successful when you understand how it works. You'll be better at troubleshooting it when you have it in your own shop. So the basic concept of how rotary broaching works is you've got two things. You've got a pilot hole on the workpiece that you've already pre-drilled and chamfered. You're going to have a broaching tool, a cutting tool that's going to be the size of the profile that you're looking to machine, and then you're going to have a holder that tilts that cutting tool at 1 degree relative to the workpiece. But also on center line of the workpiece. That's the most important part right there. You need to have that broaching tool aligned to center line as best as you possibly can on the equipment that you're working with. The 1 degree gives it its cutting action. So you can kind of think of the broaching tool as a chisel that will scallop its way into the workpiece as it rotates. And a good visual way of kind of just picturing how that works is imagine like a cookie cutter. You'd have a handle on it with a shape, and you're going to push that into the dough that you're going to be shaping. That's the same kind of motion that this broaching holder generates when it engages the workpiece. So each corner of the form gets a chance to be in the pressure zone, and it slowly scallops its way into the pre-drilled pilot hole. And it's as simple as that. And then you can see how, because it's working in this manner, having your center line aligned between your broaching tool and your workpiece is critical, because if you're off center in any way, then you're going to have more pressure loaded up on one side than another, and it's going to give you a form that's going to be unacceptable. Your tool life won't be where it needs to be in terms of having a reliable and stable process for producing pieces. So those are things to all keep in mind, where and your setup is going to be really important. You're going to make sure that everything's on center. That's very, very important. Another thing that I always like to get into, because the Swiss style holder relies on precision gauge length tools. So you can see in front of me, I've got, excluding these two, these are all tools that are designed for this particular holder. And even though we've got one here that's about 40 thousandths of an inch, and over here we've got a 3/8 square, they're all on the same overall length broaching shank. So when you put it into that broach holder, it's at a predetermined set length to put your center line of the broaching tool in the center line of the shank on the back of the holder. So again, it's all reliant on that to make sure that your center positioning is good. So the next piece we want to go into, we've actually got a really good demo video that shows how your hole prep would go, as well as the actual cutting action. And this is something that we ran in a vertical machining center using some polyacrylic. So the really cool thing about it is you get to see the cut from the side through the material as it's happening. So the first step of the process when you want to run this kind of a product is you want to make a nice stable pilot hole or a spot for it. Then you're going to drill it out to your diameter that you're going to be doing of your flat to flats, a little bit oversized, I should say. About 1% oversized is the goal. You want to have a little bit of a clearance on each flat, so that way you're generating 6 individual chips. We always recommend boring if you can, because then you can really control the size of the hole prior to broaching. And then you're going to bring your broaching tool in contact with the workpiece. And keep in mind, this is in a vertical mill, so the tool's not moving, the holder is moving, but it's still giving you that oscillation, that wobbling, that cutting action that generates the flowing chip in front of the form. So you can see here that one of the things that we have to do is leave a little bit of clearance at the bottom of that bore for chip accumulation. That's probably one of the biggest drawbacks of rotary broaching. You need to have room for that chip. It's not going to evacuate in the same way that a helix would on a drill. Those chips are going to push forward. And one analogy that I always like to give is think about like a bulldozer pushing a pile of dirt. Eventually, that pile of dirt is going to pile up to the point where the bulldozer can no longer push it. It's the same thing with your machine tool when you're doing a rotary broach. So you need to be kind of careful of that with your feeds on your broaching tools. You want to make sure you have just enough room in there for that material to accumulate without packing up to the point where it overloads the machine. Ways you can control that is leaving a little bit additional space beyond the hex depth of cut, so that way you have some space for the chips. Other ways to control it is with your pilot hole. So we showed in the video earlier that we used a boring bar. You could use the boring bar to really fine tune the diameter of the hole to find where you can get that good balance between hex size and pilot hole size and chip size. So that way you can get to the depth of cut that you're trying to achieve. On the screen now is a diagram kind of showing an exaggerated orientation of the broach tool relative to the pilot hole. So a good application for broaching is usually somewhere around 1.5 times the flat to flat diameter. That's kind of the sweet spot. You can go deeper than that, but it's really driven by material hardness and material cutting properties, as well as maximum pilot hole that's allowed. So, like I said, a bigger pilot hole will make a smaller chip, which means you can go deeper. Up on the screen now is a very good example showing the hexagonal profile with the pre-drilled pilot hole. exhibited by the dotted line. And as you can see, it's really just kind of knocking out the corners instead of a full form. So you're getting smaller chips in a scenario like this. That's going to be your ideal rotary broaching scenario right there. And that's what you want to aim for. In our catalog and on our website and all our support literature, we always say 1% is the rule of thumb for the pilot hole diameter. But my personal rule of thumb, if you've ever called me up and talked to me about rotary broaching, is how big of a pilot hole can you get away with and still get this part to pass QC? That's really what you want to be doing, because your tool life is going to be better. Your stable, your process is going to be a whole lot more stable, and you're gonna have a much easier time running it, where you don't have to worry about the chips giving you issues with tool pressure or evacuation. Removing them after the fact with a drill is key, and they're much easier to remove when they're small. So again, we're talking about good and bad applications here, and what you got to watch out for. Like I said, a good application is somewhere around 1.5 times D with enough room beyond the hex form for chip accumulation. So you want to watch out for that kind of stuff. There's also limitations on shape. So you definitely need to have a polygon shape that's regular and symmetrical, because it's being driven by the workpiece. And if you were doing something like, I get a lot of calls about keyways. A lot of people want to rotary broach keyways. You can't rotary broach a keyway because it's an irregular form. It needs to be the same all the way around, like a hex or a square. Hexalobes or Torx forms are also really good applications for it. But if it's something like a keyway where it's rectangular and you've got a long side and a short side, it's not going to be driven by the workpiece in a way that is going to give you a good engagement between the workpiece and the broaching tool. And you'll get some interesting things happening in that case there. Plus, the chip load is going to be significant, and it's just generally something that should be avoided. There's also limitations on timing on a workpiece. So if you've got a workpiece that has like a flat or a cross hole that needs to intersect with the shape that you're cutting into it, rotary broaching, you can see this is just a free spinning bearing in the holder. You can't really control where this lands. So if you've got a feature on the external of a workpiece that you have to align to one of these flats, or the hex needs to be oriented in such a way, then something like this is really difficult to make work in a scenario like that. So that's where we kind of step over to what we call index broaching or punch broaching. And that's where this guy steps in here. So you can see on the, as an example, I've got in the end here, a rectangular form broach. This can be used to generate a hex in 3 indexes by punching once, indexing, punching again, and then indexing a third time and punching it again to make a final form. And it also gives you the opportunity to clear chip in between each of those hexes. So the chip is always going to be your enemy. That's the thing you're working against. This gives you a little bit more control over it. It's not going to be as fast as a rotary broach. A rotary broach, you're looking at 5 seconds at most to generate the form, where something like this, depending on how many indexes you have to do, that's going to add some cycle time. But oftentimes people are doing this on the subspindle side of a Swiss machine after the rest of the operations are completed. So it's free time in that case there. And a lot of times you'll have some time to do some index broaching on a CNC Swiss machine. So this is really good for situations where you just don't have a good way of controlling chip and you need to remove it between those impacts or indexes. So this gives you a little more control. Plus you can time it, because we've got a flat on the broaching tool, we've got a flat on the shank, and then it's also timed to the positioning that you're going to have it in the machine. So you'll know where the orientation of the tool is relative to the workpiece. So you can clock it using your C-axis, for example. And that way you know exactly the way that it's oriented. But if you're doing something simple like a Torx or a hexalobe or a hexagon on the end of a fastener, then the orientation doesn't matter, and rotary broaching is a great way to apply that. Some of the other forms that you can do with a rotary broach is internal splines. It's actually a very good product for manufacturing that sort of a form, or some people refer to it as an ID knurl. I've heard people refer to it that way as well. Something that is meant to maybe engage in a final assembly between two pieces, but doesn't have the same level of precision as like an involute gear or an involute spline or something like that. It's not really good for gear teeth because of the way that the cutting action occurs. You can't control things like pressure angles and that sort of thing. But it is very good for like an internal serration or an internal spline, or again, any kind of polygon, squares, hexagons. We've done octagonal forms before on a few requests for customers. So that really kind of brings it through the technical side of the presentation. Going back a little bit into the products here that we offer at Gen Swiss. So like I said, one of the first products that we introduced as a company 20 years ago was the Swiss style 2160 series broaching holder, meant for Swiss style lathes. This also crosses into other types of equipment if you're going to be doing smaller polygon sizes. The range that you can accomplish with this particular product is anywhere from about 40 thousandths, 35 thousandths of an inch sockets, up to, I think, as largest as we've done is about 16 millimeter or 5/8, driven by what kind of material that's going to be. At the high end of that ceiling, it's really going to be limited by what kind of material are you broaching. So if you're doing like aerospace aluminum or brass, softer materials, the bigger stuff is possible using this holder. And you could utilize this on a vertical machining center. You could utilize this on your Swiss style lathes, of course, which it was originally intended for. Or you could use it on a bigger turning center where you have X and Y adjustment built into the turret. If you have X and Y that you can use your control to dial it in, you'll be able to do the requisite centering. So as I mentioned earlier, Swiss machines are very accurate when you bring your ID position up to center. But on something like a turret lathe, you might be out by a couple thousandths of that tool position on your on the block that's installed on the turret relative to the chuck. You might be out by a couple thousandths, and that's too much for rotary broaching. You have to have it aligned. So you can either utilize a indicator on your chuck and bring it over to the broaching tool and just kind of sweep it in that way to get it fine-tuned and centered if you have the ability to adjust X and Y using your control. But if you don't have that capability, then we do have another product for that. And this is beyond Swiss machining. This is kind of a more general purpose rotary broaching product. And it is more in line with the older types of equipment that was available out there to the market. So this is our heavy duty style CNC broaching holder. It uses the same series as broaches as our Swiss lineup, but it has a more robust bearing pack. And it's also center adjustable. So if you're on a turret machine that only has X, that axis controllable from the control, you can use this to set it up. You can see on the flange here, we've got X and Y coordinate adjusting screws built into the shank. If you look at the two halves sandwiched together, if you look very carefully, you can see that it's tilted at that requisite 1 degree angle to make the chiseling action work. And then you have the same free spinning bearing on the front and your adjustment bolts for loosening and tightening the two halves on the holder. So you would loosen the front of it and adjust your X and Y coordinates using the screws on the back side of it. You could put your indicator up on the broaching tool at the cutting tip is actually where you want to go. Oftentimes I recommend people use a gauge pin instead of the broach itself, but measure out at the same distance as the broaching tool. That's where you want to sweep your broaching tool in. So as I'm showing here, you can use the indicator on your chuck and bring it in. Another way that you can kind of cheat that, if you want to do, it's a less accurate way, but another way that you can center these is you can loosen the 4 screws on the front and make a setting plug that you can chuck into your lathe with a diameter already pre-drilled in it that's bigger than the point-to-point of the hex broach that you want to generate. And then you can bring over, manually jog your turret over and engage the 3-jaw chuck with the broaching tool in the holder, and then center it and let it float itself into the setting plug that you've made. And you can make this out of brass or aluminum, some scrap material you got laying around. And then once you have it in there, you're pretty close to center in that regard. And now you can lock the two halves together using the screws on the face. And you should be close enough at that point to start generating sockets nice and reliably. So this is what we generally recommend for machines that only have one axis of travel and are bigger than a Swiss style lathe. So like it would be really good for Mazaks, Akumas, Nakamura, those kinds of pieces of equipment. And we actually have a design that's even bigger than this one. We do have one that's a little bit heavier duty that uses 12 millimeter shank broaches or half-inch shank broaches for heavy duty applications. So we can do custom forms generally in about 2 to 3 days. We keep a lot of these rounds in stock, ready to go. So if there's something that you need that's not available on our website or not in our catalog, we can usually turn that around really quickly for you. And then if you get into something really specialty, like some of these spline broaches, for example, something like this, we'd be able to turn around in a couple of weeks. Generally, something like this requires custom grinding. So there's a little bit more detail on a product like this, but it's also something that we definitely have in our repertoire and a lot of experience in making sure that our customers are successful when employing this type of a product. So I think that covers just about everything that I had that I wanted to go over here. We'll see if there's Tim here, if we've got any questions maybe from the audience.
Yeah, so I will. It looks like we haven't gotten anything in the chat yet, but um, we did get some questions ahead of
Great.
time. And I'm going to put those up now.
Excellent.
So the first question that we were asked is, what are the key considerations when selecting a rotary broach for a specific material or application, and how do these factors influence the overall performance and longevity of the tool?
Okay. So I think we did cover some of that earlier in the presentation. So key considerations are, first and foremost, it's going to be how deep does that socket need to be machined? If it's really, really deep, then that's something where maybe a rotary broach is not necessarily the way to go, because you are limited by diameter versus depth, and then the chip accumulation. And then also in that regard, chip accumulation is also dictated by the material. So harder materials are going to limit how deep you can go versus softer materials. And then lastly, your pilot hole size is critical. If you can do a pilot hole that's a little bit oversized, then you can do a little bit more capability in harder materials. But if you're trying to do like a full form and you're in some very hard material, something like that will affect performance. It'll affect tool life between the bearings and the holder, as well as chipping out tools. But another thing to keep in mind here at Gen Swiss, we are a rebuilding facility for live tooling, and broaching holders is something that our technicians really like doing because they're very simple and easy to work on. So we do have that capability of getting you up and running again quickly.
That's very cool. The second question that came in was, can you walk us through some common challenges machinists face when working with rotary broaching, particularly in polygon machining, and how can these be effectively mitigated with the latest advancements?
Okay, so that question right there is the answer right here. This is the holder that came out to solve that problem. So one of the biggest common challenges was people would struggle to center the broaching tool. When you had the big adjustment style holders, that can be challenging to get it set up in a timely manner. And sometimes they would even kind of get it close enough and then just start running it. And that's going to affect tool life. It's going to affect part quality and that sort of thing. So this holder, the non-adjustment style, was developed specifically to make that part of it easier. This is like setting up a drill, especially when you're running it in a Swiss lathe, because you don't have to do any of that center setup anymore. You're simply touching off, and as long as your tool position is accurate, your broach tool is going to be to center every single time. So this made it much, much easier for setup. That's probably the biggest hurdle. The other hurdle we went over, again, it's the chips. The chip, I find a lot of new users of rotary broaching just don't give proper consideration to how much room that chip really does take up inside that pilot hole. And a lot of engineers, for that matter, when they design the part in the first place, not necessarily understanding how much room they need to have in that hole for the chip volume. But again, as I was saying, you can overcome that with pilot hole size. And if you have enough tool positions, you can add a boring bar to the mix and use the boring bar to increase that. You can kind of sneak up on it, get closer to that diameter. That's the sweet spot where you make a really nice hex socket, but at the same time, you're controlling that chip, you're keeping the volume down, and you're getting good tool life. So those are the good ways of answering that.
Very nice. And the last question we have is, how do you see the future of rotary broaching evolving, especially in terms of integrating new technologies or techniques that could further revolutionize polygon machining?
So, as I said at the very opening, rotary broaching's been around for a very long time, and it's a very simple concept once you kind of pull back the curtain there, and you reveal the Wizard of Oz behind it. It's a really simple process. So I don't see a ton of advancement in the future from on this particular process. I could still see it being very relevant on any precision turned components where you have to have some kind of a drive feature. It's always going to be relevant in that regard. But what I can see a little bit of starting to occur is integrating this type of tooling into attachments that are live on the machine. So, say for example, you want to do a hexagonal profile and you have a flat bottom hole with not enough room for clearance. Maybe what you would do is have a tool that would kind of nibble the form in rather than oscillate and shear its way in, and it would be driven by the live tooling motor on the machine. So it'd be more of a an actual like cutting tool, similar to like a live tool where you'd be using a drill or an end mill, but it would be kind of shaping its way in. I could see more and more in that sort of a thing coming down in the future. In fact, I think there's already some of that stuff out there to a degree out in the market now. I would just personally like to see more of it that's small enough to fit CNC Swiss lathes. And I think that's kind of where Gen Swiss works into the mix there. It's probably something that we could spend a little more time engineering and researching. So,
All right. Well, I'd like to open up to the audience. This is just a last chance to ask any questions you might have. If you see on your screen, there should be a little chat box where I've left a message. So feel free to ask any questions that you might have. And
you can always have chances later. You can give me a call. I'll be at my desk all afternoon and the rest of the week. So you can always
yes,
call and give me a chat.
and if you would like to reach Scott, you can email him at either techsupport@genswiss.com. I think that's your
That's
main
the
one.
main one. That would be the best one to reach me at for any kind of broaching application. I'll jump on that right away for you.
Okay, so the first question, will a rotary broach holder's bearings wear out faster when used broaching in a tough material such as Inconel 718 versus titanium or 316 stainless material?
Okay, that's a good question. I should have went over that earlier in the presentation, but it definitely puts more wear and tear on the holder, especially Inconel. Inconel is a very tough aerospace alloy. Actually, one of my favorite applications for Inconel, not broaching related, but it's turbo impeller shafts because I like turbocharged cars, and they use Inconel for that. It's very heat resistant, but from that, it's also a very tough material, so it's hard to broach, and it's kind of rough on the broaching tools as well as the bearings. One advantage that we do have with this particular holder that we reviewed earlier, it does use a shorter overall gauge length for the broaching tools, which puts the cutting face closer to the center line of the bearings in the bearing housing. So it's less like a springboard or a diving board out here. So it's going to actually resist those pressures a little bit better and give you a little bit more durability and reliability of the holder. But those kind of materials definitely exhibit a lot of wear and tear on your tooling. But this particular style holder, the bearing packs are very inexpensive. You can get them for about 1/8 of the cost of a new holder, plus like an hour's worth of labor service time. And we can do that here at Gen Swiss. We can service those and get them back to factory new specs. So when you are doing tougher materials, I usually advise folks, especially if they're doing high volume production, to go forward with maybe having a spare holder. So if you do have a situation where your bearings start to wear out because you're broaching Inconel all day and you're starting to get a little bit of drag and resistance here, that can affect the cutting profile that you're going to be getting on your workpiece. Swap in a fresh holder and get this one over to me. We'll turn it around to you in a couple of days. And you'll be able to have kind of a constant flow of your tooling so that way your production never really goes down.
Awesome. That was a great answer. Thank you. And we had another question come in. Uh, asking if there is any way of getting rid of the 3-degree squareness.
3 degree squareness. So I'm not sure what they're referring to on that entirely.
Okay.
There is an effect that occurs when you rotary broach. We call it helixing or spiraling. Maybe they're referring to that because it's usually could be a couple of degrees where it was actually very apparent on the video that we did earlier as a demonstration. You could see it because we did a very deep depth of cut, and it becomes more apparent on deeper depths of cut. You get a twist of the form as it goes into the material, and usually it's not a lot. It's pretty negligible. So when you take an Allen key and you put it into that socket, it's still going to clear all the way to the bottom of the hole and function correctly. But sometimes you got a really tight tolerance hole, and that helix, which I guess maybe could result in being 3 degrees potentially, that helix could cause a binding issue. Either if you're using like a go no go gauge system to check these as like a plug, that could cause a binding issue. And a lot of times people will go, oh well, the hex is undersized, and it's actually not. It's the correct size. It just happened to be about halfway down. The twist got further than your gauge will allow you to go in. So one thing that you can do to remedy that, rotary broaching doesn't care about which way it's rotating. You could rotate it one way or the other, and it'll still do the same exact cutting action. So a drill, obviously, you run a drill or an end mill backwards, you're going to have a bad time. But you could run a broaching tool either direction, and it doesn't care. As long as there's a rotation, it's still going to get the wobble cutting action. So to prevent the helix from occurring on your workpiece, you could broach about 50% depth, stop your spindle, and then spin it the other way, and then continue to advance into your workpiece. And so that'll make your spiral kind of go like this and then go like this. And that's usually enough to get you by where your go gauge will work, and you won't have to worry about the binding. So that's, I imagine that's what that question was asking. I can't think of anything else that might be applying to.
All right. Thank you for answering those 2 questions. And I think that's all the questions we have. So it was an amazing presentation, Scott. Thank you
Thank
for
you.
thank you for joining us and presenting with your very high quality production set. Cameras, the quality of the shots. I was able to see all the tools with like crystal clear vision. It was
Awesome.
nice. So thank you for joining us, and I hope everybody who watched had learned something and enjoyed their time. So feel free to reach out to either me or Scott with any questions you may have after, and we will be sure to get you an answer.
Thank you, everybody.
Oh, well, looks like we got a question in actually.
Oh, sweet. Right in the 11th hour there.
Ah, Bob, okay. There is going to be a copy of this webinar. This will be available on ctemag.com/webinars, and you will, right after I end it, it should be put up there almost instantly. So you can watch the recorded version of this webinar. And with that, I will go ahead and close it out.
Awesome. Well, thank you again, Tim. It was fun.
And thank you, Scott.
All right. Take care now.
You too.